multiplied by the distance of which it covers will give you the value for a point load. Okay, that's how you simplify it. So that 2 kilonewton per meter multiplied by 2 meters will give you a 4 kilonewton of force. Okay, now this has to be represented correctly in the diagram. So I'm just going to remove that so that you will have a clearer view of what I'm going to do now. So this 4 kilonewton will now cancel off all this uniformly distributed load, and it will sit at the middle of the uniformly distributed load. So it will be simplified as a point load, and it will be sitting in the middle. Okay, if it covers 2 meters, then it will be sitting in the middle, which means that at 1 meter from both ends. Okay, and that will have the value of 4 kilonewtons. All right, let me show you another example. Don't want to get confused. Let's try one more example. Okay, let's assume that we have been there. Okay, let's say we have support there and there, and we have a uniformly distributed load there. Okay, and let's assume that the distance between these two is 2 meters. The distance for this is 3 meters, and the distance for this is again 2 meters. Okay, just an example. And let's assume that the value for this uniformly distributed load is given to you as 3 kilonewton per meter. Yeah. So, like I said, the method of solving for this problem is similar to what you have done in the previous video. It's all about using the concept of moment, taking the force, multiplying it with the perpendicular distance, taking it to the pivoting point. It's all similar. But when you have a uniformly distributed load in your question like that, what you need to do is you have to simplify that first. And the simplification is very easy. You just have to take the magnitude of the uniformly distributed load that's given to you and multiply it with the distance that it covers. Okay, over here, this uniformly distributed load covers a distance of 3 meters. So we just have to multiply them across. So 3 kilonewton per meter multiplied by 3 meters will give you 9 kilonewton of force. Okay, so we have to take this 9 kilonewton of force and represent that correctly in your diagram. So I'm just going to take this away so that you will be able to understand, or you'll be able to see clearly where this 9 Newton will be. So this 9 Newton will be directing at the middle of these 3 meters, at the middle of this, or at the middle of the uniformly distributed load. Okay, right at the middle, 9 kilonewton. So that means that all this uniformly distributed load is cancelled off and is represented by one single load. And then you just start working on it as usual, as how we did in the previous problem. So RE multiplied by the total distance, 9 multiplied by total distance equivalent to 0, and then finding RA and RB accordingly, like what we did in the previous video. Okay, now I'm going to show you one example from the slide. Okay, let's look at worked example 2 on slide number 27. Okay. Right. So on slide 27, we have beam like that, and you can see that there are supports RA and another support RD, and you have a uniformly distributed load distributed throughout the beam. Okay, and on top of that, you also have a 5 kilonewton force there, a point load, okay, a point load of 5 kilonewtons there, and a point load of 7 kilonewton there. And we have certain distances that we need to take into account. Here we have 2 meters, another 2 meters here, another 1 meter there. Right. So like I said, what we need to do now is to firstly simplify your uniformly distributed load. As you can see, the uniformly distributed load is